For our part 2 of differentiation rules, we're going to discuss the sum rule, the product rule, and the quotient rule of differentiation. Let's start with the sum rule of differentiation. If f and g are functions, and if h is a function defined by h of x is equal to f of x plus g of x, then h prime of x is equal to f prime of x plus g prime of x. If we have f of x is equal to x squared plus 3x plus 2, to get the derivative of this function, we're just going to add the derivative of its term. So we have derivative of x is equal to the derivative of x squared, which is 2x raised to 2 minus 1, plus the derivative of 3x, which is 3x raised to 1 minus 1, plus the derivative of 2, which is equal to 0, which is equal to 2x raised to 1 plus 3x raised to 0. Simplifying further, we have 2x plus 3. So our derivative is f prime of x is equal to 2x plus 3. If we have f of x is equal to 2x cubed plus 3x squared plus 2x plus 1, then its derivative is equal to 2 times 3x raised to 3 minus 1 plus 3 times 2x raised to 2 minus 1 plus 2x raised to 1 minus 1 plus 0, which is equal to 6x squared plus 6x plus 2. Therefore, our derivative is f prime of x is equal to 6x squared plus 6x plus 2. With the product rule of differentiation, it says here that if f and g are functions, and if h is a function defined by h of x is equal to f of x times g of x, or h of x is equal to the first function times the second function, then we have h prime of x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So if we have f of x is equal to the quantity 3x plus 2 times the quantity 2x minus 3, where the first function is 3x plus 2 and the second function is 2x minus 3, then its derivative is equal to the first function, which is 3x plus 2, times the derivative of the second function, which is 2, plus the second function, which is 2x minus 3, times the derivative of the first function, which is 3. Multiplying 3x plus 2 times 2 and multiplying 2x minus 3 by 3, we have 6x plus 4 plus 6x minus 9. Combining like terms, we have 12x minus 5, where 6x plus 6x is 12x and 4 plus negative 9 is negative 5. Therefore, our derivative is equal to 12x minus 5. If we have f of x is equal to the quantity 3x squared plus 2x times the quantity x squared minus 4, where 3x squared plus 2x is our first function and x squared minus 4 is our second function, then its derivative is equal to the quantity 3x squared plus 2x, which is the first function, times 2x, which is the derivative of the second function, plus the quantity x squared minus 4, which is the second function, times 6x plus 2, which is the derivative of the first function. Then we have 6x cubed plus 4x squared, wherein we multiply 2x by the quantity 3x squared plus 2x. Then we have 6x cubed plus 2x squared minus 24x minus 8, wherein we multiply the quantity x squared minus 4 by the quantity 6x plus 2. So using the FOIL method, we have x squared times 6x is 6x cubed. Then x squared times positive 2 is positive 2x squared. Then negative 4 times 6x is negative 24x. Then negative 4 times 2 is negative 8. Combining like terms, we have 12x cubed plus 6x squared minus 24x minus 8. So our derivative is 12x cubed plus 6x squared minus 24x minus 8. With the quotient rule of differentiation, it says here that if f and g are functions, and if h is a function defined by h of x is equal to f of x divided by g of x, where g of x is not equal to 0, then h prime of x is equal to g of x times f prime of x minus f of x times g prime of x, all over the square of g of x. So if we have h of x is equal to 3x plus 2 over 2x minus 3, where 3x plus 2 is our f of x and 2x minus 3 is our g of x, then h prime of x is equal to the quantity 2x minus 3, which is our g of x, times 3, which is the derivative of f of x, minus the quantity 3x plus 2, which is our f of x, times 2, which is the derivative of g of x, all over the square of the quantity 2x minus 3, which is the square of g of x. So multiplying 3 by the quantity 2x minus 3 minus the product of 2 and the quantity 3x plus 2 all over the square of the quantity 2x minus 3, it is equal to the quantity 6x minus 9 minus the quantity 6x plus 4 all over the square of the quantity 2x minus 3. Applying the rule in subtraction of integers, it says that we change the sign of each term of the subtrahend, then proceed to addition. So we have the quantity 6x minus 9 plus the quantity negative 6x minus 4 all over the square of the quantity 2x minus 3. And so we have h prime of x is equal to negative 13 over the square of the quantity 2x minus 3. If we have h of x is equal to 3x squared plus 2 over 2x cubed minus 3, where 3x squared plus 2 is our f of x and 2x cubed minus 3 is our g of x, then h prime of x is equal to the quantity 2x cubed minus 3 as our g of x times 6x as the derivative of f of x minus the quantity 3x squared plus 2 as our f of x times 6x squared as the derivative of g of x all over the square of the quantity 2x cubed minus 3 as the square of g of x. So multiplying 6x by the quantity 2x cubed minus 3 minus the product of 6x squared and the quantity 3x squared plus 2 all over the square of the quantity 2x cubed minus 3, we have the quantity 12x to the fourth minus 18x minus the quantity 18x to the fourth plus 12x squared all over the square of the quantity 2x cubed minus 3. Applying the rule in subtraction of integers, we have the quantity 12x to the fourth minus 18x plus the quantity negative 18x to the fourth minus 12x squared all over the square of the quantity 2x cubed minus 3. Therefore, we have h prime of x is equal to negative 6x to the fourth minus 12x squared minus 18x all over the square of the quantity 2x cubed minus 3, where negative 6x to the fourth comes from the sum of 12x to the fourth and negative 18x to the fourth. Then rewrite negative 12x squared and also rewrite negative 18x.